I'm Jonathan Deneau, currently an independent researcher, and this video is about recent work looking at common interpretability assumptions in machine learning model explanations. It was jointly conducted with Jeffrey Bigham and Zico Coulter at Carnegie Mellon University. This video itself is short, meant to be a visual abstract, but if you are interested in learning more, there's a paper, data, code, and experiment at the URL at the bottom of the slides. For this work, we're interested in looking at three interpretability assumptions. The first of which is that simpler models are more interpretable. Second, model agnostic methods like LIME and SHAP are data and user agnostic. And lastly, that any explanation is better than no explanation. And to investigate these assumptions, we conducted a large-scale human subjects experiment on Mechanical Turk with 796 participants. Each participant was presented with explanations of two black box models, and they were asked to choose the more generalizable model based on the explanation shown. Here's an example of the interface for one of these pairwise comparisons. Participant is shown two explanations of two models, algorithm 5 and algorithm 6, and asked to choose which one they think is more generalizable and how confident they are in that choice. For this experiment, we are interested in four different factors. Two between subjects factors of the sparsity of the data and the explainer or explanation method itself, and two within subjects factors of the top-end features shown in the explanation and the item or data example itself. The experiment is live at this URL, so if you want to experiment with the experiment, you can go and see what the participants went through, and everything's anonymous and there's no data collected. To understand how these factors influence interpretability, we fit a Bayesian item response model where we modeled a person parameter and an item parameter. In this item response model, the person parameter represents the ability of a person to pick the more generalizable model, and the item parameter, or the data example parameter, corresponds to item easiness, or said another way, how interpretable is the data example itself. And we additionally modeled a variety of covariates that relate to the factors and the different levels of the factors. Here shown is the 95 and 50% credible intervals for the estimates from our model, and the points are the medians. I won't go through and explain every one of these, but the salient takeaways from this are that data sparsity has the largest effect among all the covariates. It has more of an effect than the actual explanation method itself. The person and item effects often outweigh the explainer effects, so who the end user is and what data is being explained can matter more than the explanation method itself. And lastly, explanations don't have monotonic utility, so there isn't one explainer to rule them all. Certain explainers work in certain contexts. Here, if we look at the interaction between sparsity and ridge regression, we can see a fairly negative parameter. But if we look at just the ridge and just the SHAP parameters, all else being equal, ridge performs as one of the best explainers. With this research and with all research, there's always limitations and always caveats. For us, we only looked at one data and one task with 796 people. Interpretability itself is epistemologically fraught, I say, in that there isn't really a clear, easy, direct way to measure it, and everyone has different proxies of what interpretability is to them. And lastly, it's just a really big design space to search through of domains, methods, parameters, and lots of things to vary and experiment with. But in conclusion,